name it from the top of my head, but I do follow like specific hashtags, not necessarily followers. So I follow a lot of hashtags on bug bounties, red team hashtags, and different techniques. That's how I usually go and look for new information.
Okay, interesting.
Awesome.
Yeah, but you,
Yeah,
Megan.
for me, I would say Clint Giebler from Return to Corp. He has a newsletter called TLDR, right? So the newsletter is pretty good as well. So usually there's him and a few other folks that I kind of, okay, if this person tweets, I want to be notified, right? I can get a notification from them because it's usually something interesting, something good. He usually shares like different open source projects or interesting articles around AppSec and cloud security, which is basically my area. So yeah, definitely follow Clint. Mhm.
Interesting. Okay. Yeah, I mean, I think in terms of my red team sources, it's mostly like Spectre Ops, as well as the the usual suspects from Microsoft. Forgetting them right now, but yeah, predominantly Spectre Ops. And in terms of source code review and stuff like that, I think that where I get most of my information from is honestly OWASP as well. But yeah, those are some great resources. Is there any maybe blogs that you follow, or do you guys write blogs yourselves?
Yeah. So for me, I do write on Medium. So I follow a couple of people there as well. But for Medium, I mostly just do my own writing. So anything from dissecting specific exploits, which I've done previously, or talking about new 0 days that's been published or something like that. So yeah, I post a lot of my blogs on Medium as well, but not always about technical stuff, but also about giving advice on people how to break into cybersecurity, or resources for them to study if you want to break into offensive security and stuff like that. So yeah, I do enjoy writing quite a lot. So
Nice.
Yeah.
Yeah. I have my own blog, which is katanasec.com. I created this blog in the beginning of the year, I think. Yeah, and I try to push myself to publish at least one article a month, but even that I failed. It didn't work out.
That's a
Like,
lot,
okay,
you know.
yeah, one article a month, yeah, and especially with the like because of my own research, I have to publish that through the company's blog as well. So it's hard to find other topics and find time to write. But yeah, there's many different blogs that I like to read, especially the ones that are very like technical and explaining attacks and vulnerabilities and talking about source code reviews. I can't name some of them off the top of my head, but I can share some links later, and it's definitely it's like a mix of everything. It's usually I get the reference from Twitter, and then I go like read the blog and find more information about the article there. But yeah.
Very true. For anybody who is listening to this and they don't have their own blog, I highly recommend it. Simply, based on just learning. I like back when I was in school, I used to write a blog just to like actively learn things. And when you have to publish a blog post, it kind of forces you to really understand what you're writing about, because in some ways you are teaching that topic to a wide audience. So you have to make sure that like you understand the topic in order to be able to explain it. So highly recommend it if anybody else out there doesn't do it yet. But it looks like we've been talking for a few minutes and people are here. So let's go ahead and get started. But before I begin, a couple of housekeeping notes. If you have any questions or comments, feel free to leave that in the chat. We'll be periodically checking it and asking it to our guest speakers. If you need CPE credits or you have any feedback, please use the link in the description of this video. Just a way that we can understand how we're doing and if there's any way we can improve. On top of that, if you're looking for work or you're hiring, please comment that in this description of this video as well, or sorry, in the comments of this video. Ignatius, we're starting with you and in your lightning talk. Are you ready to go?
Yeah.
All right.
I'll be sharing my screen now. Can you guys see it?
Yeah, the floor is yours.
Cool. So hold on. Cool. So again, hi everyone. Thanks again for attending today's OWASP session. So the purpose of this lightning talk is really to make you guys aware of OWASP projects, what they are, and how you can essentially access them. So OWASP projects are essentially a collection of open source projects, tools, documentations, manuals, and other related things that have been developed by groups of talented individuals. And you can contribute to these subsequent OWASP projects by essentially connecting to the specific individuals who are responsible for those projects. So on my screen here, I already put the URL where you can check out a list of different OWASP projects that are available, to the public. So it's again owasp.org/projects, and this is where you will be able to see a list of different projects that everyone has applied for and has been approved by OWASP organization. So another way for you guys to contribute aside for contributing to a specific project is to essentially start your own OWASP project. And to do that, again, you can just go to the URL that I have on my presentation here. And on the right hand side corner, you will be able to see a link, which I've highlighted here for you to be able to start a new project. In order to start a new project with OWASP, you need to have an account. So if you click on that link, it'll ask you for your information to sign up. And once that's done, you can then go ahead and request to start a new project if you do have one in mind. Now, in this presentation, I will be going over one of OWASP projects called G0rking, which is essentially a tool that is developed to perform and automate Google dorking activities, which is really cool. Now, before we go any further to the tool itself, let's take a step back and just to kind of briefly talk about what Google dorking is. Now, Google dorking, for those of you who may not know it already, it is also known as Google hacking, which is essentially a technique that is often used by people or security professionals to find out very specific information about organizations. So it could potentially help attackers to identify security weaknesses, discover sensitive documents, or other informations that are relating to the targets. So for example, specific files that contains specific words, technologies that are being used by specific organizations, credentials, admin management portals, and many more. So there are sample queries that I've included here. So if you go on your web browser and go on Google search, you can, you usually search for, other type of subjects, but you can also have a parameter or list of parameters that you can use to narrow down your searches on Google. So as an example, on the very first query here, I have a parameter that says site equals or colon owasp.org and file type colon PDF, which on the right-hand side, if you can see my screenshot, essentially shows that I only want to query files with PDF extensions that are coming from the website owasp.org. There are also other sample queries online that you can find. For example, ExploitDB has a cheat sheet containing different Google dorking queries that you can use. You can, again, look for specific files with different extensions. So for example, my second query shows an example of, I want to look for files with an extension of PDF, XLS, and doc that contains the tax confidential salary that has been published on Google after January 1st, 2021, and so on, right? So it's pretty powerful tool to narrow down your searches, and you can find possibly sensitive information through Google dorking. Now let's talk about G0rking. So essentially, again, as I mentioned previously, G0rking is a Google dorking script which was developed by a few individuals who call themselves the Blue Virtual Nerds. I have included their GitHub repository on my presentation here so that you can see the other things that this group has made. This tool was developed in Python 3, and it essentially allows you to perform Google dorking activities without the need for you to go to your web browser and entering the Google Dork queries. It also allows you to save the search queries so that you can refer it back in the future. And the good thing about it is that you can integrate this tool as part of your automated information gathering pipeline process, which is really cool. One of the most useful function of G0rking is probably the URL probing function, which essentially allows you to execute several queries at once on a specific targeted website. So to install G0rking, again, if you have a Linux system, you can just git clone or download it from the GitHub repository that I've provided. And once that's done, you need to extract the zip file, and then you want to change the directory to the G0rking directory. And the next thing that you would want to do before using it is to install the list of requirements that G0rking needs. And once that's done, you can simply just execute it using Python 3 space G0rking. Now, the screenshot that I've shown you, I hope it is visible enough, but this is one example of the G0rking usage, which essentially, again, you can see that Python 3 space G0rking, that's how to execute the actual tool. And then it will have two different options for you. The first option is generic dorking tool, which essentially allows you to kind of search for specific query strings. So in this example, I have included, step 1, would you like to save the result? And I've said no because for the purpose of demonstration, I'm not going to save that to my machine. And after that, you can see the step 2 here. It will ask you for the dork search query string, which in this case I've shown file type PDF and site twitter.com, which essentially I want to grab all the files with PDF extensions from site twitter.com, which then it will display the results here at the bottom. It will ask you. It will also ask you how many of these searches that you want to display. In this case, I put 5, but you can put anywhere between 10 to 200 results, right? The second function is really cool. This is the URL probing function, which again, essentially it executes a list of queries that are contained in the dorking topdb.txt file. And it will execute this search queries onto a specific website. So on the second screenshot here, as you can see, I have included the OWASP.org as part of my target. And once you specify your URL target, the tool itself will execute all of the lists, all of the queries that are contained in this file, and perform that searches against the targeted website. So yeah, so I would say just give it a try. I've included the links for the G0rking project in my presentation as well, and I think you'd be able to do some cool stuff and integrate that to part of your information gathering pipeline for this one. Yeah, I'd recommend checking it out. I'll give it back to Adam to proceed for the next step.
All right, thank you, Ignatius. Are there any comments about G0rking that the audience has? My first question to you, Ignatius. So you're a red teamer. Are there any Google Dork commands that you can recommend as things that you could?
Yeah. So one of the more common ones are usually for management. For example, if you want to look for specific management control or management portal, what I commonly use is the site parameter, which is the targeted organization that you're trying to launch your attack on. And I would usually put intax, which is intax parameter essentially tells you, hey, I want a specific result that contains this specific text, right? And I would usually put cPanel or some other CRM or any web framework services that they have. And more often than not, you'll probably gonna discover some management portals that belong to that specific organization. And as we all know, low hanging fruits is pretty common, and you could probably just get by using default creds, and that's probably one of my favorite things to find on Google Dork. So it's pretty cool.
Yeah, totally. It's always fun to find default creds on an internet exposed web application.
Yeah, for sure. Yes.
I'm just seeing that we have a couple of comments, but they're just links like the exploit DB URL that you mentioned, as well as the G0rking official tool web application. Okay. I would just, I guess, give it a couple more moments to see if anybody has any questions.
Sounds good. Another thing that I forgot to mention is actually, for the URL probing function on G0rking, you can actually build your own list. So if you don't want to have, specific parameters or search queries that you want to launch against a specific website, you can just delete that whole entire query database and just supply it with your own, so that it gives you a more customized search. And then you can use those queries as well to kind of launch your searches against the specific URL target, which is really cool. Yeah.
Yeah, it sounds really cool, especially if you had a lot of different domains that you could go after.
Yeah, for sure. Yes.
All right, we have one comment, but it's just asking or saying that they hope that we're all doing well.
Oh, cool.
Yeah, Matt, I hope you're doing good too. Yeah, and you mentioned kind of before this presentation went on that you had a bit of an issue with it. Were you trying to do something trying to use the tool in a unique way that caused the crash?
Yeah, so interesting about it is I think it has something to do with the threshold that Google put in place in the amount of searches that you can, like how many queries that you can do that. Because I do notice that whenever I'm not using the tool, I usually just do manual searches on Google with these parameters. I usually get a CAPTCHA type of a CAPTCHA screen from Google. So I think that might be what's causing it. So if you guys are talented developers and specialize in Python who can contribute to bypass that CAPTCHA, that would be pretty cool.
Yeah, interesting. I wonder if there's a way to maybe hook it up with like AWS or some kind of cloud provider to be able to come from multiple different IP addresses. So
yeah, I think that'd be pretty cool if you can kind of automate or switching the changing the IP address from different EC2 instances or somehow and do it that way, right? So just kind of bypass that CAPTCHA protection that Google has, which is pretty annoying. But
yeah, absolutely. So it doesn't look like we have any questions from the audience here. Do you have any last minute things to say or plug while we have you?
I think not from me. Again, I do want to plug my blog again. It's popalltheshells.medium.com. So I write about exploit breakdowns there, about my discoveries as a red team ops and all of that stuff. If you guys interested in checking that out, just come by and say hi.
Yeah, I've read it myself. I highly recommend it, and we've already linked it in the chat, so you can see that poptheshells.medium.com.
Cool. Thank you.
Of course, and thank you, Ignatius. All right, so now we have our other presentation for this evening. Megno, are you all good to go?
Sure. 1 second, let me share my screen.
All right.
Okay.
All right, Megno, the floor is yours.
Awesome. Thank you, Adam. Okay, yeah. Hello, everyone. Thanks for joining for this session here. Today, we're going to talk about software composition analysis, a bit of a one-on-one talk, right? Knowing what's inside your apps. I started this research on SCA about 2 years ago, 2019, when I was applying for kind of a scholarship to participate in an event in Belgium. It's called SecAppDev. That's when the topic caught my attention, and I started doing more research about it. And then when I moved to Trend and started working with vulnerabilities and research as well, that topic always came to mind related to kind of supply chain attacks and everything that we're going to see today. So I presented this, I shared this presentation in different talks already. I think the latest one was at Sector in Toronto in person. I think was my first in-person event after this whole pandemic, which I don't know if it's over yet, but yeah, we'll see. But yeah, let's start. At the end, we're gonna have some demos, so make sure that you stay tuned until the end. Okay, so just a little bit about myself, right? I'm an information security specialist and like senior threat researcher at Trend Micro. I've been in application security and for over 10 years now, and doing also a little bit of DevOps and DevSecOps lately. I teach a course on secure coding and DevSecOps as well. I taught that during the OWASP event last month in November as well, so that's interesting. And yeah, I deployed multiple tools, SaaS, DAS, and SCA. And some of them work, some of them don't work, right? So we need to understand it's not just about the tools, the process that you have, and there's also a lot of false positives. So it's very important. And so SCA is kind of it's the new kid on the block, if I may say that, for AppSec. Right, a lot of organizations already had a DAS tool, right, for dynamic analysis, and other organizations also had the SAS tool for static analysis. But not a lot of organizations had, at least a few years ago, had a SCA, right, a software composition analysis to look at the dependencies and libraries that you have in your code. So we're going to talk about that a little bit more in detail in this presentation, and understand why this kind of tool or this kind of approach and solution is important. As I mentioned in the beginning, I also have a blog called katanasec.com, right, where I try to write some articles there. I started in the beginning of this year, as I mentioned, and I try to write like one article a month, but I failed miserably because of work and other things. But there is, I think, the latest article that's there from June is related to SCA, right? So it's related to this talk. So you can go there and take a look at the article as well. There is also on the blog, there is also all my previous presentations since 2011, since I started presenting at tech conferences and events. So OWASP as well. I was a OWASP chapter leader back in Brazil for over 5 years. And yeah, there's also all my contact information, social media, which is basically LinkedIn, GitHub, and Twitter. It's all Magno Logan, so you can easily find me there. So yeah, let's start. Okay, so the agenda for today, right? So understand a few different terms and a few different concepts, right? So understand what is SCA, what does it mean? There's a lot of different kind of synonyms and other words that people may use to refer to this kind of approach and this kind of tools. Understand what is a BOM, right? A BOM, or bill of materials, right? And an SBOM, a software bill of materials as well. So that's important to understand those concepts and understand what these tools are doing when they're generating an SBOM. Then we're going to talk about why should I worry, right? Maybe if you're a developer, you probably don't update your libraries, right? And so what is the problem here? Why is that relevant? And why is SCA becoming a big deal on many organizations? Or there is a lot of other kind of commercial versions of tools out there. Then we're going to talk about supply chain attacks, because that's kind of a big thing when we talk about SCA. You're inheriting a lot of libraries and dependencies from other people, and you don't know where they come from, if they're kind of malicious or not, right? So understanding that's very important. Talking about some best practices regarding SCA, and mentioning a few tools out there, some commercial and open source as well. And then I'll do a demo with Snyk, right, which is a has a free version of a software composition analysis solution, and you can just start scanning your projects if they have like public repos right away. So you can do that as well if you want to follow along. So that would be fun. Okay. So software composition analysis, right? There's different terms, as I mentioned, right? So some people may refer as library analysis, third-party dependency, or even open source security, right? And what's the idea here? Why was this created? Developers nowadays, they don't write code from scratch, right? So they usually inherit and import other people's code and libraries that do something that's kind of very common that they need in their code. Let's say authentication or authorization, session management, right? So they don't need to rewrite and reinvent the wheel. They just inherit that code and call that function or that method, right? And what happens is that they're trusting that code to run in their applications so that they can focus more on the business logic, right? The most important part of their application, the logic of the main features, right? So what happens, right? When they inherit that code and like, okay, you're trusting them, you're running some code, or are you scanning that code? Are you checking if the libraries are up to date, if they have any kind of public vulnerability? Usually not, right? So that's kind of the idea here with SCA, software composition analysis. The goal is to provide, right, with the open source software, we usually, right, you have to, when you inherit those code, usually they're open source, so you have to control where they come from, right? Is it like a project that's being constantly updated and maintained? When was the last version published, right? Is this developer trustworthy, right? So this kind of things. But you also check for security, checking if there are any known vulnerabilities in those libraries, and also checking the license. That's another important thing, that if you're inheriting a library and some code that has an open source license, but it requires you to share your code, right? So maybe you don't want to do that. So like a GPL license, I think, is the one that people are usually afraid of. I don't want to use that source code because it might come with consequences. So the idea here is to understand, like, what is my list of dependencies? What do I have in my application? And usually it's not a list. We're going to see here, especially in the demo I'm going to show, it's like a kind of a tree of dependencies and dependencies of dependencies that generates a lot of complexity in solving this issue. So there are a lot of tools out there that try to solve this, and we're going to see a few of them. But it's not that simple. It's not just, oh, just update the library, right? So what happens if I update the library and it breaks my application? So there are some nuances here that we're going to figure out along the way here. Okay, so to have an SCA tool, right, a software composition analysis tool, I need at least three things. So I need an application manifest, right, which basically tells me, okay, how the application works, how do I build it, what do I need for the application to run. Okay, I need the dependency metadata, which is basically a list of dependencies, the name of the libraries and their versions. So it can be like the POM XML for Java applications that run on Maven. It can be a package.json for JavaScript or Node applications as well. Different languages have different ways to represent the dependency metadata. And you need a vulnerability data source, right? So if I need to compare, if I have a list of libraries and versions in my code, and then I need, okay, is this up to date? Am I using the latest version of this library? Or does this library has any public known vulnerability? So I need something to compare to, right? So I need a vulnerability database or a vulnerability data source. And it can be a public database or a private one, right? So the most kind of well-known public database of vulnerability is the CV, right? The NVD database, which is basically a list of CVs. But some organizations and some tools out there, they create their own databases because they have more information than some CVs. Some vulnerabilities related to open source applications and libraries don't have CVs. So relying only on the CV database, it's kind of, okay, you're already missing a lot because some of these vulnerabilities are found by developers or maintainers of that project, and they don't care about CVEs. They just submit a pull request or at least open an issue to fix that problem in their library, and they're not going to create a CVE. It's not important for them. That's usually important for us as security professionals, right? We want to publish our CVEs or have a CVE under our name, but not for developers or open source developers, right? So it's like, so how do you collect that information? So it's important to know if I can't rely on the public databases. It's important if I'm even like purchasing a license of a commercial tool, is this tool, does this tool have a private database? Is it good enough? Is it only relying on NVD for their vulnerabilities, right? So just some things to keep in mind here when you're looking for a solution or testing a solution like that. Okay, so what is a bill of materials? In the real world, right, a bill of materials is basically a list of components to make a product, right? As an example here on the slides, you have like basically, okay, a shopping list of items, where they come from, the manufacturer, their models, and the suppliers, right? And the price. And also the quantity, the units that I need. So I need all that to create a product. So think of as a list of ingredients of a packaged product, right? A packaged food. So, okay, I need all these ingredients. It doesn't say exactly the quantity, but I need all these ingredients to make up my product. So it's the same thing with the software bill of materials. The software bill of materials is the list of ingredients that make up my application, right? The list of components in this piece of software. Right? It's usually open source, right? Open source libraries and tools, but it can have some commercial ones as well, and even some proprietary ones that I created in my own organization. So yeah, it's like, as I mentioned, describes the components in a product, right? And it's similar to a list in a packaged food. So we're going to see about that, the software bill of materials, very clearly in the demo. So we want to generate that to make sure that my software bill of materials is always up to date, right? And it's always using libraries that don't have any kind of critical vulnerabilities. So it's important to maintain that. So if today it's hard for us to even maintain a list of assets in our organization, think about maintaining a list of assets of the applications in our organization, right? So that gets even more complicated, especially if you don't have a solution or some kind of automated way to help you do that. So there are some resources out there. Even OWASP has a great one now, which is called the CycloneDX. So there's no standard right now. This new approach, the SBOM, or the way of controlling and managing your dependencies, it's kind of pretty new. So there is no standard. There's different standards that people create. And it's like, okay, we haven't come up with one that's, okay, this is the one that we're following. So there's different ones that you can use. So for OWASP, as I mentioned, there is CycloneDX, which is basically a standard of a lightweight software bill of materials. The CycloneDX project, they joined OWASP earlier this year in June. Right? So there is a blog there talking about this project joining OWASP as well. You have SPDX, which is another standard from the Linux Foundation to control you're kind of communicating, right? Having a list and showing that list to other people before they use your application on the software bill of materials. And you can also track that. You can also track not just the direct dependencies, but also the indirect or transient dependencies, as we call them. You can track that using different tools. And you have OWASP Dependency Track, which allows you to identify and reduce the risk of the software supply chain. So you have the Dependency Track, which we're going to talk about later, and you also have the Dependency Track. So there are two different projects in OWASP just to help you with your software composition analysis, which is really good. Okay, so yeah, you talked about this stuff and SCA, and it's a new tool that I need to install and run in my pipeline in my organization. But like, why should I worry, right? Why should I care about this? Okay, there's two studies here that I brought some data and some interesting information out of it. The first one was done by Synopsys, right, last year to 2020. And basically, they analyze a bunch of projects and open source libraries and code bases. And the results were that 80% of all the code bases that they analyzed had at least one vulnerability, right? So 84% of all your libraries and dependencies had at least one vulnerability. But the average of vulnerabilities was 158 per code base. So 158 vulnerabilities per code base. And another thing here is that the average of components on the right side here, the kind of the graph there, the average of components that make up an application in 2016 was 84. So kind of 84 direct and indirect libraries were part of a new software, a new application. But nowadays, at least since last year, 2020, you now have an average of 528 components there. So it's like 528 direct and indirect libraries that you need to be aware of and take care and see if they're up to date and if they don't have any kind of security vulnerability. So it becomes much more complex and even harder to do if you don't have an automated way or a process to scan these applications and find those issues, right? And even Snyk, which published the State of Open Source Security Report in 2019, they analyzed the number of packages or libraries being created every year per per language, right? So they have here Maven, which relates to Java package, NPM, JavaScript, Nugget, .NET, and PyPy Python, and Ruby Gems Ruby, right? And we can clearly see that for JavaScript, there's a lot of packages being created, right? So you have libraries of libraries of libraries. It's like you basically don't need to write any code anymore, right? You just import some packages and boom, your application is done, right? You have even libraries to check if your number, like if like to sum two numbers, to add two numbers, right? Or to check if a number is even or not, and like it's crazy. It's crazy. There's a lot of packages out there. So that adds a lot of this kind of interdependencies between them and a lot of complexity, and also creates some security risks. So this is why you need to worry about that. Okay, but I'm still not convinced, right? So I still think that I can trust the dependencies or the open source in my application. Okay, if you have Dast and your SaaS tools there to scan and test your application dynamically, that's great. But are you scanning the code inside those libraries, right? So are you doing any SaaS analysis inside that open source libraries that you have? If not, then you have a problem. And the problem here is the code cocktail, right? It's something that was presented by Mark Curphey, one of the founders of OWASP. He had a company called SourceClear, which got acquired by Veracode in 2018. But when he made this presentation, right, talking about the code cocktail, and there's a lot of research behind that. Right? They say that kind of 10 to 30% of your application's code is your custom code, the one created by your developers. And 70 to 90% of your code is open source. It's dependencies, it's frameworks and libraries, and all the things that create and help create your application are part of that open source. So you have this kind of cocktail. And if we're talking about attack surface, if I want to cover most of the attack surface of my application, right? Most of the issues that attackers can find and exploit in my application, should I focus on the 10% custom code or the 90% open source code? Right? So maybe it's important to leverage that as well. That's a big attack surface for attackers to exploit. And usually those libraries, as they are open source, they can have access to the code, and it may be even easier for them to find vulnerabilities, right? They don't need to have your application's code to know how that library works, right? Okay, so as I mentioned, there is the issue of direct dependencies, the ones that you directly inherit in your code, and that may become even more clearer on the demo. But there's also indirect dependencies, right? So let's say my library also depends on 2 or 3 other libraries, and it inherits them when it's running, when it's calling a method or something. I don't see that dependency directly on my application, right? On the dependency metadata. I can't see that. So I need a tool that pulls that information, such as Dependency Track, and shows me, okay, how deep is my dependency, right? The list of dependencies that I have, which are can create a lot of problems, right? So maybe your library is up to date, but the library that your library uses is not up to date and is vulnerable. And we've seen that as well with Docker containers. So Docker images, right? They usually have packages over packages and everything. And so that's why I have this kind of image here. It's related to a research that we did on a threat modeling on Kubernetes and Docker as well. And we published this as okay, this is a matter of concern, right? Those images and libraries, we need to know where they come from and if they're up to date and not vulnerable. Okay, if you still don't believe me, at least trust OWASP, right? Trust the OWASP Top 10. The Top 10 2021 was released this year, right? And it has, still has an issue related to open source components. So on the 2017 version, we had the A9 related to using components with known vulnerabilities. And then that got changed, the name changed a little bit, and it was it moved up to the 6th position. So it's an A6 now, and it's vulnerable and outdated components. So this means that this issue is become even more complicated to deal with, right? So it's a bigger risk of a vulnerability for web applications. As you know, the OWASP Top 10, it ranks this list, the top 10 list is by rank. So right, so the first one is kind of more important than the second one, and so on. So it's becoming even more critical for you to be aware of what your dependencies are and if they're up to date and if they're not vulnerable. Okay, but what about the supply chain? What is this? What is this kind of? How does this relate to supply chain? Basically, right, you have a process of developing code and shipping code. You have your CI/CD pipeline, right? And you have your libraries that you maybe inherit from an internal repository or an external one. So it depends, right? It's going to depend on an organization. But you need to be aware that if you're trusting that code, those libraries, and they're compromised, there are many different ways in your pipeline that an attacker can inject that malicious library in your code, and that gets built into your build systems, and it's going to generate a malicious package or a malicious application. You may have a backdoor, you may have a kind of an infected library, mining cryptocurrencies. You can have many different things. So this was the issue related with SolarWinds as well, with their build systems. And there is a lot of news out there. Even today, I just saw one related to malicious packages, right? So the attackers either publish a package or a library to their repository, let's say npm, which is the most common one, and it's a malicious one. Okay, but how, if it's a malicious one, how they trick users into downloading them? They usually use a similar name as a famous package, or which is even more harder to identify, is that they compromise the developer's account. The developer, they find the developer of that package that has a lot of downloads and a lot of people are using. They compromise that developer account, and then they get their credentials, of course, and then they ship a new update of the library that they're working on with a malicious code, which is even more critical, because now everyone that's relying on that package that's downloading, it's going to download the latest version, and now they're compromised as well. So that's even more critical, and that keeps happening with npm and Python and everything that has a central repository for packages is kind of vulnerable to this kind of attack. There's many a list of supply chain compromises here as part of the CNCF, the Cloud Native Computing Foundation. I helped them with the security tag team, which is called Technical Advisory Group. And we kind of have this list of supply chain compromises on our GitHub there. So the latest ones that we have, the CodeCov and Homebrew, and also the SolarWinds one is there. So it's usually related to some developer tool or infrastructure that's related to the pipeline that was affected. So they're not targeting the application directly. They're targeting the components or the people involved in creating those components for the application, right? So it's like they're usually always looking for an easier way in. So you need to be aware of that. There's different samples here. There's other examples on this list. There is even, I think the first one was from 2003 that we tracked. There's a lot of other, maybe even more there. So if you find another one that's not on this list, feel free to submit a pull request to us. That would be great. We also publish a supply chain white paper. So besides the Cloud Native Security white paper that we released last year, this year we worked on the software supply chain white paper. So it was a group effort on the CNCF, the Cloud Native Computing Foundation, on the security tag team to write and create some best practices. Okay, how do I secure my source code, right? How do I secure my binaries, my artifacts? How do I secure my pipeline? So like, okay, we learned how to protect our networks, right? The attackers were focusing on the networks. We learned how to protect the networks. The attackers kind of shift to applications. We're still learning, but we're better than before on protecting applications. So now attackers are shifting to the build pipelines and build systems because that's usually not protected. So we need to learn how to protect those. So this supply chain white paper has a lot of great information and details. It wasn't written only by me. There's many different professionals from different organizations such as Apple, Google, I think Microsoft, and others that put their kind of thoughts and effort in this paper. So it's really great, and I really recommend you take a look. And it's very important for protecting your supply chain. Okay. My developers, they code they don't use IDEs in their computers. They use something like a VDI or now cloud IDEs, such as AWS Cloud9 or VS Code Online, or even I think it's GitHub Workspaces. I don't recall the name. So there's different IDEs now that you can just write your code there and have all your code in that in that application, kind of a IDE as a service or a cloud IDE. So we also analyzed that earlier this year, I think was last year, if I'm not mistaken. Earlier last year, our team at Trend Micro that does security research, we also analyzed this. Okay, is coding in the cloud kind of safer than using IDE? And this blog here has a lot of information, so I'm not going to get into too much details here, but this is also an issue with supply chain attacks. If someone compromises that service, let's say the AWS Cloud9, and they're able to manipulate or inject some code into other people's code that's out there, then that's a big issue, right? So you need to be aware of those as well. Okay, the last thing before we go into the demo is like, okay, if you don't believe me, if you don't think that's still important, if the SCA is not a tool that maybe you should think about or a process that you should implement in your organization, let's talk about the US executive order, right? Which is something that was published earlier this year in May. And it was published by the US president, right, Joe Biden there. And in this order, one of the topics there, one of the main sections, it talks about enhancing the software supply chain security. And it says that any kind of organization or company that sells software to the US government, it should have a list of their kind of bill of materials, right? Our dependencies, making sure that they are up to date and making sure that they don't have vulnerabilities. So I hope that this kind of expands to other countries as well, and Canada and Brazil and Europe, right? And Europe. I know Europe's not a country, but yeah. but yeah, the idea is like, okay, now they need to demand, they're kind of demanding from organizations that they need to have that. They need to have this list. This list should be up to date. And okay, if this library is vulnerable, why were you still using, right? There's a funny story from yesterday's AWS outage. I don't know if you saw that, if you noticed in the outage there was, the marketplace, the AWS, the Amazon marketplace for you to kind of purchase AMIs and VMs there. It was giving like a stack trace, right? So when you try to access during the outage, it was showing an X stack trace. And on that stack trace, it was showing that it was running Tomcat. But it was running Apache Tomcat 8.5 something, which is, I think it's a pretty old version of Tomcat. And like, okay, maybe AWS is not following the best practice here, right? So you need to be aware of that as well. Like, okay, are you trusting that service or that organization to protect your information, and they're using outdated software version, right? Let alone the whole issue with the regions and everything right now having kind of a disaster recovery or high availability. I'm not gonna get into that, but it's like, okay, yeah, I can clearly see, I even took a screenshot and I can show later, but like, yeah, this is a big deal, right? So supply chain and having systems up to date and having like, okay, it seems like kind of basic, but you're going to see in the demo that's it's not as easy as it seems. Okay. So some other tools that you can use, right? I mentioned the OWASP Dependency Track, which is the one that's provided by OWASP. It checks Java and .NET and some other languages as well. It even has Retire.js embedded to it, so it checks JavaScript libraries. It's I think one of the best ones out there that's free, but it's limited to the NVD database, right? As I mentioned, it's restricted to CVEs that are published regarding those libraries. If there is no CVE, it's not going to find anything. So you have Retire.js. You can even install Retire.js as a plugin on your browser. And every time you access a website that has a kind of outdated or a vulnerable JavaScript running on that website, Retire.js will flag it for you, right? So it'll let you know. So that's kind of cool. You have Snyk, which, as I mentioned, it's I think one of the best tools out there for software composition analysis, and it's even free for open source. And we're gonna see the demo here with Snyk. You have open source security by Trend Micro, right, which is basically based on Snyk, powered by Snyk, as I may say. You have the Veracode SCA, which is also a commercial tool as well, and it can be they integrated, as I mentioned in the beginning, right? They acquired the SourceClear company that belonged to Mark Curphey, one of the founders of OWASP, and they kind of integrated that into their own product, which they had already won, but they made it. I think they made it better with SourceClear. And there is BlackDuck, which was acquired by Synopsys a few years ago, also does some great software composition analysis. Okay, that's all I had for content for sharing. Now I'm going to move into the demo. So if you have any questions, feel free to share them and post them in the comments, and we'll go along with the demo. And if you have any questions about the demo as well, feel free to share those as well. So in the demo, I'm going to show, right, basically before we move into the demo, I'm going to show how easy it is to integrate a repository, let's say from GitHub, into my SCA tool and scan it for vulnerabilities. And then we're going to analyze the results and see about the direct dependencies and indirect ones and all those things. Okay? Sounds good. Let me just stop sharing here, and I'll share my browser. Okay. 1 second. Okay, Snyk. See, can someone share my screen to the video? Okay, great, thank you. Perfect. Okay, so Snyk is a tool, right? A company that provides this. It started as a software composition analysis tool mainly. Now they do more than that. Now they have static analysis, and they analyze infrastructure as code and Docker files and everything. I'm not going to talk about that. I just think they're great for what they do and the service that they provide in regards to kind of offering their tool and their service for open source projects. So you can really leverage that for your organization. So I'm going to log in here. And when I log in, I can easily link that to my GitHub account so that Snyk sees all my repositories that I have on GitHub, and will be able to easily scan them. Okay, let's see. Live demos are always hard, but I hope this works. Okay, I have this kind of, I'm not going to go into the interface and everything, but I have this kind of dashboards. I have the reports, projects, some integrations. There are some great integrations with other tools, such as like Jira, and you can publish your issues there. You see that my GitHub is configured, but I can use other source code management tools such as GitLab and Bitbucket and all that stuff. So that's great. But what we're interested in is projects, right? So here I have all the kind of projects that I'm analyzing or monitoring with Snyk. Okay. But those ones are not important. I want to add a new one. Let's add a new application for Snyk to scan. So I can go here to add a project, and I'm gonna select GitHub because I want to Snyk to look at one of my codes from GitHub. Okay, so once I select GitHub, Snyk is gonna load kind of all my repositories, and you can see that I have a lot of them here, but mostly forks. It's fine. But I'm gonna select one. I'm gonna select this goof. Goof is a vulnerable JavaScript application, like a to-do list that Snyk created, and that we usually use for trainings and for showing kind of their dependency analysis, and kind of we can also even exploit a vulnerability that's on the library that Goof is using. So we're going to use that. Could be anyone, could be any other tools, any other repository. It just needs to be in a language that Snyk supports. Basically, down here, I have some settings that I can enable. Let's say if my dependency metadata file is not where it's supposed to be, it's in a different location, has a different name, I can set it up here. But for my project, for my Goof project, I know that it's on the package.json, which is in the root directory. You can also tell Snyk to exclude some folders, right? So some folders may have some kind of test files that you don't want to be flagged as a kind of false positives. So you can ask it to exclude this one. These ones are the default ones that it has, but you can add more if you want. So I'm not going to touch anything here. Basically, just type my repository and selected that for adding. Okay, just clicked on the checkbox here. Okay, once I do add select repositories, Snyk is going to right away add this repository to my list. You can see it here. It's still not showing, but should be there soon. And it's going to scan it. So what is it going to do? Let's take a look at GitHub. Let me share my I think I need to be on this screen. Okay, let's wait for the, so I don't switch tabs. Let's wait for this scan to finish, and then we're going to see the results. And then I can go to GitHub from this tab here. Okay. So now in kind of less than a minute, a few seconds, Snyk already scanned my repository, which has this Goof application, and it has 3 results, right? So there's the code analysis. As I mentioned, there are new modules now on Snyk, and I'm not getting any money out of this. I'm just showing and teaching you about a cool project, cool tool that has a free service for open source. So it has code analysis. It has analysis on Docker files. So if you have any kind of Docker images and Docker files that you're building images in your repository, it looks for issues and best practices there as well. But we're not interested in that. We're not going to look at that right now. What we're interested in is the package.json. The package.json is the file that has all my libraries and dependencies in my code, in this JavaScript code, okay? So clicking here, and I was able to see right away, let me go back. Even before clicking, I can see that, okay, here is the number of vulnerabilities, right? So I can easily see that there are 3 criticals, 39 highs, 38 mediums, and 6 lows. And if I click here, then it's going to show me the list of libraries, right? And so I can see here the list of libraries. I can see the CVEs for the ones that have CVEs. For example, this one doesn't seem to have a CVE related to it, right? So it's not all vulnerabilities, as I mentioned, have CVEs. I can see here when this vulnerability was introduced, in which version of the library. Shows here 0.2.24, and which version it was fixed. Oh, it was fixed on 0.2.25, just the next one. Okay, that's great. I can just update to the next one. Yeah, I can. We're gonna see about that in a second. There's some information here, detailed path. There is some overview about the vulnerability itself. You can even access more details of the vulnerability going here and clicking on this link, which goes to the Snyk database and the intelligence feed that they have of all different vulnerabilities in those libraries. But there's also some information here talking about exploit maturity. What does that mean? This is like, okay, for this vulnerability, there is an exploit code published already, and it's out there, right? It's a working exploit. It's not a POC. It's working. So you just need to download the code and run against a vulnerable application that has this library, and it should work. It should exploit that vulnerability of prototype pollution. So that's critical. So Snyk uses that, not just the CVSS score, but also the exploit maturity to, and also if it has a fix available, to kind of create a risk score, right? So it's like a priority score. Which one should I fix first? Is it this one? Is it a critical or is it a high one? So we have two highs here and there's a critical down there. Like why this one should not be prioritized yet? Because this one, there's no exploit yet for this one. So there is no code out there that someone can use to exploit this vulnerability, although it's critical. These other ones that are high should probably be prioritized. So that's another great thing as well. Okay, so there's two options that I can do here with those findings. Basically two options. One option is I can ignore. If I know that this is a false positive, I can ignore it. It's usually hard to see false positives on those issues, but usually if it's like transient dependencies, right, the dependencies of dependencies, it can be tricky, but you can ignore those. Or you can tell it to fix it. Fix this vulnerability. What does this gonna do? This is going to open a pull request in your own GitHub repo to fix that vulnerability. So let's try to do that. Let's try to do this right away. And I'll show here later the dependencies and everything. Okay, so remember that name, type your, because once we fix that, the vulnerability should not show up. And we have 86 issues. Okay, should go down to 85. Let's see if that's going to work. And I can show here right away with the fix vulnerability. Since I gave Snyk permission to my repository, it's able to kind of submit this pull request. I click fix vulnerability. Basically, it's going to open a fix PR, as I mentioned, and I can select all of those issues that I found here. I can do that. I can just check the checkbox, and it's going to try to update all of those. But what's the problem here? If I try to update all those libraries at once, it probably is going to break my application. And it's going to be hard for me to find which library was the one responsible to break my application. So it's better to do like step by step, especially in the beginning, to make sure that your application keeps working after you update the libraries. So that's one of the most common issues that we see with developers. They don't want to touch the code or the libraries because usually when they update the library, the application stops working and now they need to fix that. So yes, there are some issues when there are some occasions when you update a library, it can break, can change your application behavior or the library API changes and everything. So it may break your application. That's true. But there are some ways to kind of assess if this is a breaking change or not, and how to do this update little by little makes it easier for you to identify any issues. So it's important to have proper testing, so that, like, especially regression testing. So to make sure, okay, I changed this part here, but I want to make sure that other components that relied on this part is still working, right? So this is kind of regression testing. Make sure that the application is still working after some changes. Okay, so I'll leave this library here, this only one that we're updating. I'll leave this one selected. And I'm going to go down to the end. Okay, open a fixed PR. Let's see what this does. Okay, usually takes a few seconds, but it's probably going to go to GitHub. It should go to GitHub and show us the pull request. Okay, yeah, now we see it. So now we can see that, okay, who opened this PR? It's this Snyk bot, right? And it's opening that on my Goof application, my repository, and it's telling me security upgrade, right? Type ORM 02.24 to 02.25. So it describes here basically what we saw in the report at the Snyk dashboard, the vulnerability. We can see that's a prototype pollution. There's a link to their database. It shows here breaking change. So this helps you when you want to update your libraries. Is this a breaking change or not? Okay, it's saying no. Why? Why is it saying no? Usually, when you update libraries and you just update kind of the minor versions here, right? The 24 to 25, and not changing a lot. It's still 0.20, 0.2. So I'm not changing, like I'm not jumping a lot of versions forward, and I'm not changing a lot. So it's saying, okay, this is not a breaking change. But if it was, like, let's say here 1.2.25, right? So it's probably would be a breaking change. So when you change major versions of your libraries, there's usually some changes and some things that are not compatible with the older versions, and it might break your application. So just be aware of that. So it's nice that the tool already checks for that for you, and it can tell you if this is a breaking change or not. So yeah, it has some information here. And basically, okay, let's see the file that's changing. Let's see files change. So there's two files that were changed. One, let me go down here first. Why is it changing everything? Did I do something wrong? Package lock. Let's see. Let me hide that for now. Okay. This one, right, it's basically changing the type ORM, so the package.json file, which is the one that has the dependency metadata, right, is basically just changing the version. Okay, it's either 0.2.24 or above. Now it's either 0.2.25 or above, if I'm not mistaken. This is or above. But yeah, so just changing one number, basically, right? And the package lock.json, let's see if I can find the type ORM here. Okay. On the package lock.json, besides having the version and the name of the library, it also shows the link to download the library and the signature, right? The hash signature of that library to make sure that it wasn't modified or tampered with. So it changes that as well. So you see that there was a link for the 24 TGZ. Now I have the 25, and the signature changed completely, right? You can see that here, changed completely. I don't know why it was doing the other updates, but I can take a look. Maybe there was something else there. But this is what's important to us, right? Now I'm making sure that I'm downloading the version that I want that fix this vulnerability, and I also updated the signature. Okay, what else can I do here? And I know that we're let's see, still have time. Okay, I'm gonna merge this pull request, and after I merge this, we're gonna see that Snyk's going to update the scan results and should not show the vulnerability on this library anymore, and we should see the number go down from 86 to 85. Okay, let's merge this. Yeah, confirm merge. Okay, merge. How do I know that? I can go to my code and I can check the package.json file, and I can check the type ORM. Yeah, you can check here. I can see, right? That's only pulling the 0.2.25 again. Okay, let's go back to Snyk. Let's see what it shows there. Oops, login. Forgot to go to the app directly. It's gonna go right away. Okay, let's go to projects. And now goof. You can see that it was tested again a few seconds ago, right? Right after we changed. So there is kind of a webhook notifying Snyk that something was changed in that project, and it's going to scan it again. So it ran the scan. And now I don't see any type or vulnerabilities. Right? It's not there anymore. It even went down to 83. I think it was 86 before, because I thought there was some other libraries there updated as well, which shouldn't be, but it's fine. So we reduced the number of vulnerabilities down to 3. And that's how you go about dealing with SCA, right? You have libraries in your code and you have dependencies. Let's see this one. For example, this one, it's a breaking change. So if I send this pull request, it's changing from 0.0.24 to 2.1.3. So that's a big change. And that might break my application. So I should be aware of that. So I'm just going to create the pull request again so that we can see it. And then I'm going to show everyone the kind of indirect dependencies as well. Let me do this. Fix this vulnerability. Let's see. Yeah, this one is selected. See if I don't have any other ones selected here. No, I don't think so. Okay. So this probably should be a breaking change, because it's changing a lot of versions on the library. And so, yeah, there might be code there that shouldn't work anymore when you update that library. So it's very important to have some regression testing. Yeah, breaking change. Yes. See, now I can be more careful when updating this library, right? So it's just wanted to show you that this shows already that's a breaking change. Let me go back to Snyk again. Okay. Okay, one more thing that I wanted to show before we finish this and open for questions is this one, right? Remember that we talked about the indirect dependencies, right? The transient dependencies. Here is a list of direct dependencies. So we have about 30, 31, I think, dependencies in my Goof application that directly depend on those libraries, right? ADM.-zip and body parser and everything. Okay, yeah, this is a list. This is 31, about 30 or 31, I think. Okay, but you have the plus sign here. The plus sign, when I click here, this library, oh, this library depends on all these other libraries. And what happens? This library, it seems up to date. It doesn't have any kind of vulnerability. But there is a library here called QS that's vulnerable. And it has a high vulnerability. So how do you deal with that? Like, if there is no more up-to-date version of body parser 1.9.1, then how do you fix this issue, right? So that's where it gets complicated, gets more complex, because you either going to have to ask the developer of this body parser to download the latest version of QS and update their code, or you're gonna have to do it yourself. You're gonna have to kind of make a fork of the body parser library and make sure that this one is downloading the version of QS library that's not vulnerable. So you see how that becomes tricky. So the main issues with the dependencies and software composition analysis is it's not finding the vulnerability, right? You can see that kind of Snyk and other tools can find those. The problem is fixing. The problem is making sure that your application keeps working after you fix it, after you update those. That's why we still haven't solved this problem yet. And I think it's going to take a while until we figure out a way to completely mitigate this kind of vulnerability. So this is just one example, right? So if I open the others, and they can go down many levels, right? So like this one, and there is another one. See, there's kind of, okay, so these become kind of a tree of dependencies that it becomes very tricky and can become hard to kind of control and mitigate those issues. Yeah, I think that's basically what I had to share today about software composition analysis. I hope you enjoyed this presentation, and if you have any questions, if you'd like to know more about it, you can add this to your pipeline. You can have some GitHub actions. You can add with Jenkins, whatever. You can have this automated creating tickets, and with not just Snyk, but many other tools out there, they kind of support these integrations. So yeah, happy to answer any questions you may have around this topic, and thanks for having me again. Thank you.
Yeah, thank you for coming, Magna. That was a great presentation. The comments we have here are one from Abimbala. How would you compare semgrep to Snyk?
Okay, so semgrep is more like a static analysis, right? A SAS tool. The beauty of semgrep is that you can write your own rules. So Snyk has a SAS solution now that's based on a company that they acquired, I think, a few years ago called Deepcode. But it's still, I don't think it supports any kind of custom rules. So semgrep would be more comparable to CodeQL. CodeQL, which is another query language from GitHub. So that's the one that you can also write your own rules to look for vulnerabilities in your code. So I think that's comparing Snyk to semgrep is not a fair comparison. Would compare more with CodeQL.
Okay, yeah, thanks for that. Have you used shift left scan? Another commenter, Ibro, mentioned that. Any thoughts on that?
No, I haven't used their tool. I know someone that works there, the Vicky Lee, the one that wrote the Bug Bounty book as well. We recorded a podcast together a few months ago as well. But I haven't used their tool yet. I know that they usually have some blogs around code reviews, and they have some challenges for developers to find the vulnerability in the code, but I haven't used the tool yet. Yeah.
Okay, good to know. I have a question for you. Have you used this tool against any popular open source projects, and have you found anything interesting with that?
Yes, I did. I do a lot of the research that I do on open source security. I did one on cloud native applications, so cloud native software such as Kubernetes, etcd, and Helm, and I also analyzed those the code of the application, so the static analysis and also the dependency analysis, right? The software composition analysis there. And using Snyk and other tools, I published some articles around that. And the most recent one was related to kubectl plugins, right? So kubectl is the CLI for managing your Kubernetes clusters, and you can install plugins on your kubectl as well. And so that has a kind of a repository, a central repository where you can host your plugins and analyze those for dependencies. So I'll probably post the links here on the chat.
Yeah, that'd be great. Are these on your blog, or are these on the Trend Micro blog? Because I also love Trend Micro as well. Their blog is great.
Yeah, these are on Trend Micro's blog. Yeah.
Okay.
Trend Micro.
Yeah, to the audience, highly recommend following the Trend Micro blog. It's very good. Yeah, especially their write-ups on 0 days that have been in the news recently as well. Very interesting stuff.
Yeah, and we have a lot of positions open, and especially in Canada, right? So if you want to apply, feel free to talk to me first, and we can talk more about which position is best for you, and like what you want to do. But we have a lot of positions from not just for security, but for developers as well, and DevOps engineers. We do tons of stuff there. It's really good.
Yeah, actually, that's a great point. How can the audience reach out to you guys if they have any questions? I'm speaking to both Ignatius and Magna.
Sure. Probably my social media, either Twitter or LinkedIn. That's where I'm most active on. So twitter.com/Magnalogan or LinkedIn/IN/Magnalogan as well. So yeah, feel free to reach out anytime, and I'm very active there, and I try to answer people very quickly, and I probably can help out more there.
Okay.
Yeah. Same thing for me as well. Probably LinkedIn is the best way. But if you wanna mention me on Twitter as well, it's at PopAldashell. So all of my social media, it's all at PopAldashell. So
Very nice. Remain consistent. We have another question from the audience here. So what is the main difference between SAST and SCA? Is it just dependency checking?
So yeah, SAST looks at your custom code, right? So it's gonna read the code of your application, and it's gonna look for kind of, okay, is there any input validation? Are they making concatenated queries which could lead to SQL injection, right? So it's more related to the custom code that you have. The problem is that most of the SaaS tools, they don't go into the libraries of your application and then download their code and analyze the code as well, right? So the problem is with dependency, with the SCA, the main issue is like, okay, you don't care much about the code because you're inheriting that, so you're kind of trusting that code already, but you want to make sure that those libraries are up to date and they don't have any kind of vulnerabilities. So it's looking more on the version and CVEs and what's out there. So it doesn't really look at the code itself. It doesn't check for input validation or kind of concatenation of queries and stuff, string in queries. It doesn't look at that. So it's a bit different. It's a different concept. Yeah.
Yeah, if you're looking at how these tools work in the back end, right? A lot of the software composition analysis tools, what they do is they'll walk through your either the definition file or like the file system for the specific piece of code that you're trying to scan, and it'll take like a hash of that and then check the hash against a database um, somewhere that contains like a mapping of each of these pieces of software and their version numbers to the list of like open source vulnerabilities, and then it'll have some database of like what are versions of that piece of software that don't have the vulnerabilities and those kinds of things. So it's almost like a database matching thing, and then also like a matching of NVD and open source like vulnerability libraries to specific open source tooling, right? From a SaaS perspective, most of the SaaS tools in the backend are really a number of different things. They run a bunch of regular expressions against the code base to try to look for specific kinds of functions. And then they also do they cross compile into like quite a few of them into like an intermediary so that they can build a map of how the code actually runs. So they'll be able to do what they call source to sink tracing to find out like where stuff goes in and where stuff comes out, and actually do what's it called, execution tracing. That's what it's called, to try to
Abstract
find
syntax tree.
vulnerabilities. Right, that
Yeah.
exactly. So they'll do things like that to run signatures against that specific, it's like against a syntax tree and against an execution path to see if there are any specific kinds of vulnerabilities in it like that. So they're doing very different kinds of things to try to discover if a piece of software has vulnerabilities in it. Um, like open source co- vendors will run SAST against their own against their own products, but when you inherit some dependencies, for example, if you inherit the DLLs or like you import compiled versions, you don't get the software composition analysis, or sorry, you don't get the static code analysis on it sometimes because of the way the tools work and things like that. So you kind of want to run both to know if the industry and if like researchers think there are vulnerabilities, and then if the static code analysis tools have discovered the vulnerability, like discover, I guess, net new ones that can be fixed through coding errors.
Yeah. Yeah,
So
that's great.
the long answer of what the difference is.
Yeah, exactly. So usually you want to have both, right? So you want to have SAST and SCA, and there's even research. I think Veracode that published a great report, the state of software security. They mentioned that, right? So when you have SCA and SAST, you usually find more vulnerabilities and you fix them faster, right? Because you either find issues in your code or in your libraries, so that helps with creating a better and more secure application. So yeah.
Right. It looks like there was some confusion in the chat because SCA also stands for source code analysis as well. So there's a bit of a, you know, confusion as to what it meant in this context. But yeah, in this context, it's source composition analysis, right?
Yeah.
Yeah.
Software composition analysis. Yeah, that's the main.
If you're a Fortify user, SCA is their source code analysis engine, so it's easy to get confused when you're talking about when Magno and and this group is talking about SCA. We're talking about SCA. I think it's the category defined by Gartner now, which is software composition analysis.
Yeah, that's right.
It used to be open source component scanning or like OSS or whatever,
Yeah,
and then it got
exactly.
renamed to SCA because category naming and things like that are not consistent.
Yeah.
Yeah.
Just like that DevSecOps, right? You have DevOps Sec or Sec DevOps or Agile Security, Agile
Yeah.
SDOC. There's many different names. But I haven't seen any other tools besides Fortify to use SCA as a source code analysis. It's usually SAST or static analysis, right? But yeah, SCA today, as far as I know, most of the organizations, they understand as a software composition analysis, right? So understanding what kind of components, what kind of libraries make up your application. Yeah.
Absolutely. Were there any other questions from the audience or from my fellow panelists here?
No, but I'd love to
Good.
I'm gonna read that article on the security of kubectl because it's very interested in all of that as well.
Yeah, as I mentioned in the beginning, I have some research coming up, an article probably next month on GitHub Actions, and I'm writing a book about DevSecOps. So I talk about these kind of approaches and how to integrate that into the pipeline and everything. But the book is still in the early stages. It should be out mid next year. But yeah, probably going to have more practical approaches and how to implement that into the pipeline as well.
Awesome. I'll keep an eye out for it. I was interested in reading other practitioners like books and blog posts about DevSecOps. So
yeah, I mean, like what angle are you going to talk about with secure DevOps? Are you just going to talk about the whole pipeline, or are you targeting a specific aspect of it, or?
So there aren't, as far as I know, there aren't many books on DevSecOps that really cover the technical stuff, the how to do it and the tools and how to implement those. And like, okay, yeah, we saw it with Snyk, right? Adding the tool and scanning, it's easy. That's when the hard part comes in, right? Fixing the vulnerabilities and dealing with false positives and noise and making sure that developers are taking care of those as well, especially if it's something that they need to fix. So this kind of things that usually comes from my experience and with also with connection with other professionals out there as well. It's like, okay, what have worked and what didn't work, right? So when I moved to Canada a few years ago, I worked for a company called Skip the Dishes, right? I was their first application security analyst, and they had over 300 developers there. And so we basically didn't have any tools out there. We had to create the program from scratch. So I was adding kind of SonarQube, and then we added another solution for SCA as well. And it's like, okay, yeah, sometimes some things didn't work. we also tried a security champions program there, and that kind of worked, but it had some bumps as well. So I kind of described these stories of, okay, this worked for me, right? This is how I did it. And it's just, okay, might work for you, it might not, depending on your organization, but I try to be very practical. So very, okay, this is how to do it.
Very cool. What's it going to be called? And is it from like No Start or another publishing company?
Yeah, we're it's gonna be through Packet Publishing, and it's for now the title is kind of, okay, DevSecOps, a technical approach. But it might change at the end, at the final version, but it's like, okay, a technical approach. Okay, yeah,
Awesome.
Yeah, keep us informed. We'd once you get it released, we'd love to have you to talk about it.
Sure, no problem. Yeah, happy to join anytime.
Okay. It looks like we don't have any other questions from people in the chat. Any last words of advice for the audience, that kind of thing?
Yeah, Magna, anything else to pitch, or any other upcoming things we should be aware about?
I don't think so. Yeah, I think I kind of closed the year. I did a lot of presentations out there with Kubernetes security, and also, as I mentioned, at Sector, talking about SCA. But yeah, I don't expect any other events or anything anytime soon before the new year. Just taking a break and relaxing a little bit as well. But yeah, that's it. Just feel free to hit me up on Twitter or LinkedIn, and I'll be happy to talk more about these topics. Yeah.
Awesome. Thanks,
Yeah,
Magna.
thanks a lot, Magna. What about you, Ignatius? Any last minute words? Anything we should be aware about? Upcoming events?
No, I'll give from my end. That was very informative. I wasn't really well versed in AppSec and DevSecOps and stuff like this, so that's definitely something that's really good for me.
Awesome. Yeah, thank you guys. And anything else from Ophi or Jack?
Nope. Have a good holiday, everyone. Thanks for sticking with us all year, despite the fun we've been having in our sort of public and social economic lives. We're very lucky to have everyone as part of the audience, and all of our great speakers this year. It's been amazing. In January, we'll get back together. We're having a joint presentation with the OWASP Ottawa chapter, because us Canadian chapters are trying to pull together a little closer. And then we'll see you in January, hopefully on January 12th.
Yep, that's the tentatively scheduled event.
Yes. All right.
Cool. See you guys next year.
Everyone. Yeah. See you all next year. Have a great holiday.
Yeah, and just to close everything off, thank you guys. Thank you, Magna. Thank you, Ignatius, for your your presentations, both very great. And thank you to our audience for coming out. It's been a great year. Thanks to our sponsors as well. Don't forget to leave feedback. Have a great year. Have a great New Year's. We'll see you all in January. Be safe. Happy holidays. Take care, everyone.
Take care, guys.
Take care, everyone. Bye.
Bye.